Hi, everybody. We are here to talk about prime and composite numbers. We're going to introduce those. So in our notes, we define the basic example or difference basically between prime and composite numbers is that a prime number is a number that only has two factors. That's one in itself. That means you can't divide it by any other number. Whereas a composite number is just every number that's not prime. So to show you an example of what that actually looks like, there's this tool called the Sieve of Eratosthenes or Eratosthenes, depending on how you say it. And Eratosthenes was this ancient Greek mathematician who sort of figured out this pattern for figuring out what numbers are prime and what numbers are not prime. So it's what we call an algorithm, which is just sort of like the basic math word for a program, where we sort of apply a rule and see what follows. So we know the first couple of prime numbers are 2, 3, 5, and 7. Now that's not counting the number 1, but 1 is a prime number. All the composite numbers are multiples of one or more of these numbers. That's sort of the rule. That basically means if I can divide a number by 2, by 3, by 5, or by 7, then by definition, it's not prime. Because if I can divide it by anything other than 1 in itself, that doesn't work. So what we're doing here is we have this chart, this sieve, which a sieve is just sort of a fancy word for a grid or a more likely it's like a colander, sort of like you would see to strain like cooked pasta through or something like that. And what we want to do is cross out all the multiples of these numbers. And as we go in order, you'll kind of see there's a pattern depending on what number we're working with. And then the numbers that are left are going to be the prime numbers. So let's get right into it. We'll start with the multiples of 2, which it's telling us to use red. So I'm going to get my red marker out here. And so 2 is circled. But then when I say multiples of 2, that means we're basically just counting by 2s. So every time I get to a number where I'm counting by 2s, I'm going to cross it off in red. So we have 2 first, and then 4, 6, 8, 10, 12, 14, 16, 18, 20. And if I would continue, hopefully you're seeing the pattern here, is that every even number, meaning 22, 24, 26, 28, 30, all the way up to 100 and beyond, every even number is not a prime number. The only even number that is a prime number is 2, because the only things I can divide 2 by are 1 and 2. So by definition, it's a prime number. 2 is the only even prime number. So the way this is organized, this grid, the sieve of Eratosthenes, I can actually just look and see every other line is getting crossed off because every other line or every other column has even numbers in it. So I'm just going to cross those off real quick, and then we'll get to our next prime number, which is 3. And so then we're going to do the same process, but we're going to use a different color to sort of, show what we're doing here. And we're going to count by 3s. So now it's telling me to use orange for multiples of 3. Okay, so again, 3 is a prime number. The only numbers I can divide into 3 are 1 and 3. If I get to 6, that is a prime number. Well, that wasn't crossed off, or that was already crossed off. So, I could add an orange stripe to it as well, but it's already crossed off. 9 is the one that's next that I would cross off. And 12, I didn't cross that off. 15, yeah. 18, yep, already crossed off. 21, because that's 3 times 7. 3 times 8 is 24. 3 times 9 is 27. Looks like I'm crossing that off. 3 times 10 is 30. That's already crossed off. Then 11 is 33. 36 is already crossed off. So the pattern, as you're seeing, is as I'm counting by 3s, every other number has not been crossed off yet, so I need to cross it off. Another pattern that you can hopefully see is if you look, I'll start here with 9 as an example. if I work my way down through diagonally, even through the red, through the orange, through the red, through the orange, just keep going in this direction diagonally, I will cross off every number that is a multiple of 3. And I can do that for every diagonal row that has orange crossed off in it. So those are multiples of 3 here. I'm going to start at 30, work my way down. Those are all multiples of 3. This one here at 60, that's 3 times 20. Those are all multiples of 3. And 3 times 3, or 30, which is 90. It's all multiples of 3. Okay. So the next one has multiples of 5. I'm going to use green for these. So those are your 5, 10. Those are basically all the numbers that end in a 0 or a 5. Excuse me here. Let me get my pen up. There we go. So 5 is a prime number. I can only divide it by 1 and 5. 10 is not a prime number. That's already crossed off though. 15, 20, 25 hasn't been crossed off yet. So all the numbers that end in a 5 or a 0, which in the sieve is all the numbers in the column under 5 that I haven't already crossed off. So again, all the numbers that end in a 5 and all the numbers that end in 0. The reason I'm crossing them off is because they are not prime, they're composite numbers. The last one is multiples of 7. I'm going to use purple for that one. So this one I'm going to have to run through my 7 times tables because, if I'm looking at 7, that is not prime, but 7 times 2, 14, that wouldn't be prime. That would be composite. Times 3 is 21, times 4 is 28. Excuse me, times 5 is 35, I already did that. Times 6 is 42, I already crossed that off. Then 49, oh, I didn't cross that one off yet, that's 7 times 7. 7 times 8 is 56. 7 times 9 is 63. 7 times 10 is 70. And 11 is 77, so it looks like I didn't cross 77 off. 7 times 12 is 84. 7 times 13, that would be 21 plus 70. Oh, wait, that's 91. Yeah, I didn't cross that one off yet. 98 times 14, that's already crossed off. That's everything on my list. So here's what I have left. What I have left are all numbers that are composite. Or excuse me, that are prime. So 2, 3, 5, 7 are prime. The next prime number is right here, 11. Then 13, 17, 19. All the numbers in this chart that I have not crossed off are prime numbers. Now you can see there's not necessarily a pattern to them. So it's not really easy to predict in terms of this like grid setup. But what they all have in common is that they only have 2 factors, 1 and itself. So if you take your time to work through the Sieve of Eratosthenes, oh, there I missed one, you will hopefully notice, or you will be able to find, excuse me, all the prime numbers between 1 and 100. My last one there is 97. All right. So that's how you do this assignment. If you followed along this far, thanks for following along. Otherwise, I will see you tomorrow. So thanks for watching, everybody.